Okay, Assalamualaikum warahmatullah. We meet again in our online lecture, Chapter 5, Subtopic 5.4, LAN Design and Analysis. So, LAN Design and Analysis involve calculation of path cost. Okay, bridges use the concept of cost to evaluate how close they are to other bridges. This will be used in the STP development of a loop-free technology. Originally, 802.1d defines cost as 1000 per bandwidth of the link in megabit per second. So, cost of 10 megabit per second link equal to 100 or 1000 over 10. Okay, and the rest. Running out of room for faster switches, including 10 gigabit per second Ethernet. Path cost. This figure shows calculation of path cost. IEEE modified the most to use non-linear scale with the new values of the cost. Okay, so this is path cost. You can modify the path cost by modifying the cost of a port. BID and bridges ID and path cost are used to develop a loop-free topology. But first, the 4-step STP decision sequence. Okay, so let's see these 4-step STP decision sequences. 4-step STP decision sequence. When creating a loop-free topology, STP always use the same 4-step decision sequences. 4-step decision sequence. First step, step 1, lowers BID. Second step, lowers path cost to root bridge. Third, lowers sender BID. Fourth, lowers port ID. So these are the 4-step STP decision sequence. Bridges use configuration BPDUs during these 4-step processes. There is another type of BPDU known as Topology Change Notification, TCN BPDU. 3 steps of initial STP convergence. The STP algorithm uses 3 simple steps to converge on a loop-free topology. Switches go through 3 steps for their initial convergence. Step 1, elect one root bridge. Step 2, elect root ports. Step 3, elect designated ports. All STP decisions are based on the following predetermined sequences. 4-step decision sequence. Step 1 lowers BID. Step 2 lowers path cost to root bridge. Step 3 lowers sender BID. And step 4 lowers port ID. 3 steps initial STP convergence. As step 1, elect one root bridges. Okay, this is the detail. Step 1, elect one root bridge. When the network first starts, all bridges are announcing a chaotic mix of BPDUs. All bridges immediately begin applying 4-step sequence decision process. Switches need to elect a single root bridge. Switch with the lowest BID wins. Okay. Okay, step 1, elect one root bridge. All 3 switches have the same default bridge priority value of 32768. Okay, so you can read this. Step 2, elect root ports. Step 2, elect root ports. Now that the root war has been won, switches move on to selecting root ports. A bridge root port is the port closest to the root bridge. Bridges use the cost to determine closeness. Every non-root bridge will select one root port. Specifically, bridges track the root path cost, the cumulative cost of all link to the root bridges. So this is the way the calculation of the cost. Okay. Step 1, step 2, step 3, step 4. Step 3, step 4. Step 5 in elect root ports. Then you can read this on your own. Step 3, elect designated port. This is a listening state. The loop prevention part of STP becomes evident during this step, electing designated ports. A designated port functions as a single bridge port that both send and receive traffic to and from the segment and root bridges. Each segment in a bridge network has one designated port chosen based on cumulative root path cost to the root bridge. The switch containing the designated port is referred to as the designated bridge for that segment. Okay, root path cost, the cumulative cost of all link to the root bridges. Okay, you can read this. Okay, we will first only look at switch ports that have connections to other switches. Stages of spanning 3 port states. Okay, blocking, listening, learning, forwarding. STP states. When a bridge is first attached to a network segment, and before it can start forwarding data, it goes through a series of states while it processes BPDU and learns the topology of the network. There are 5 states in STP. STP states 5 described in table 1. So the states of the STP, 5 states. First is listening, second is learning, third is forwarding, fourth is blocking, and 5 is disable. Listening, listening, processing BPDU and building active topology. Learning means building bridging tables, no forwarding of data. Forwarding, sending and receiving data, normal operation. Blocking, a port that would cause a loop if it were sending data, so it is only receiving BPDU until a topology change, remove the possibility of a loop. And disable, a port that is manually isolated from the network. Stages in spanning 3 port states. So here blocking, listening, learning, forwarding. Okay. This is required for BPDU protocol information to propagate throughout a switch network. Topology changes in one part of a network are not instantly known in other parts of the network. There is propagation delay. A switch should not change a port state from inactive, which is blocking, to active forwarding immediately, as this may cause data loops. Each port on a switch that is using spanning tree protocol has one of 5 states. This is STP port states. Next is listening state. To determine active topology, absence of BPDU for a certain period of time can cause the bridge to transition into the listening state. No user data is being passed, however, the port is sending and receiving BPDUs in an effort to determine the active topology. The 3 initial convergence step is in the listening state. During initial convergence, any ports that are not elected as a designated or root port go into the blocking state. After the default length of 15 seconds in the listening state, designated or root ports progress into the learning state. Okay. Ports transition from the listening to learning, from listening to learning state. In this state, user data is not forwarded, but MAC addresses are learned from any traffic that is seen. The learning state lasts for 15 seconds and also called the forward delay. PPDUs are still processed. So learning state, 15-second interval during which the bridge does not pass user data frames while the bridge is building its bridging table. As the bridge receives frame, it places the source MAC address and port of each frame into the bridging table. The learning state reduces the amount of flooding required when data forwarding begins. At the end of the learning state, if a port is still a designated port or root port, it transitions into the forwarding state. The bridge spans a default of 15 seconds in each of the listening and learning state. Okay, next is the forwarding state. A port goes from the learning state to the forwarding state. In this state, user data is forwarded and MAC addresses continue to be learned. BPDUs are still processed. Remember, a switch port is allowed to transition to the forwarding state only if no redundant link are detected and if the port has the best path to the root bridge as the root port or designated port. Okay, this is example of redundant link. Okay, you can read this. Interconnecting LANs and hubs. Active central element of star layout, star topology. Each station connected to hub by 2 UTP lines. So hub act as a repeater. Limited to about 100 meter by UTP properties. Optical fiber may be used out to 500 meter. Physically star, logically bus. So interconnecting lengths through hubs. Okay, it can considered as physically as star, but logically as bus. Transmission from a station seen by all others. If two stations transmit at the same time, it will have collision. Two-level hub topology. So this is example of two-level hub topology. So you have one hub and one level and another level. Hub connected to the hub. Two cables to the pair of optical fiber. So in this, two stations connected to the hub and another two stations connected to another hub. Let's say this is hub A, this is hub B, and these both hub A and hub B are connected to another hub in order to connect to station. This station. Let's say this is station 5. Okay, 1, 2, 3, 4, 5. This is considered as two-level hub topology. Buses, hubs, and switches. Bus configuration. All stations share capacity of bus. Only one station transmitting at one time. Hub uses star wiring to attach station. Transmission from any station received by hub and retransmit on all ongoing lines. Only one station can transmit at a time. Total capacity of LAN is 10 megabit per second. Can improve performance using a layer 2 switch. Can switch multiple frames between separate ports and multiplying capacity of LAN. So this is a shared medium, bus and hub. So this is a shared bus. Okay, shared medium, hub. And this is a layer 2 switches. Layer 2 switch benefit. No change to attach devices to convert bus LAN or hub LAN to switches. Have dedicated capacity equal to original LAN, assuming switch has sufficient capacity to keep up with all devices. And using 2-layer switches, it can scale easily additional devices attached to switch by increasing capacity of layer 2. Types of layer 2 switch: store and forward switch and cut through switch. Store and forward switch, a set frame On input line, buffer briefly routes to destination port. See delay between sender and receiver and better integrity. For cut-through switch, use destination address at beginning of frame. Switch begin repeating frame onto output line as soon as destination address recognized. Highest possible throughput and risk of propagating back frame. The disadvantage is risk of propagating back frame. Layer 2 switch versus bridge. Comparison. Bridge vs layer 2 switch. Layer 2 switch can be viewed as full duplex hub. Incorporates logic to function as multi-port bridge. Differences between switch and bridges. Bridge frame handling done in software. Switch performs frame forwarding in hardware. Bridge analyze and forward one frame at a time. Switch can handle multiple frames at a time. Bridge use store and forward operation. Switch can have cut-through operation. Hence, bridge have suffered commercially. Layer 2 switch problem, broadcast overload. Users share common MAC broadcast address. Broadcast frames are delivered to all devices connected by layer 2 switches. Broadcast frame can create bit overhead and broadcast storm from malfunctioning devices. Another problem or disadvantage of layer 2 switch is lack of multiple link. Therefore limit performance and reliability. Okay, router problem typically use sub-network connected by routers. Router do all IP level processing in software. After that, we have layer 3 switches. Solution: layer 3 switches implement packet forwarding logic of router in hardware. Okay, yang ni bacalah packet by packet of load base. LAN. Okay, so we have discussed in this topic about LAN topologies and media, LAN protocol architecture, bridges, hubs, layer 2 and layer 3 switches. So that's all for this chapter. That's all for this part. Now, hopefully you can understand about these topics in chapter 5. So that's all until we meet again in another video. That's all. Thank you for your attention and see you again. Bye bye.